Hi, in this video we're going to talk about determinant of matrices. So if we have a 2 by 2 matrix, for example, let's call it A is some matrix in this form. So to find the determinant of A, okay, we also write it as A determinant with the two bars, and this is going to give you A times D minus C times B. So it is like this. Okay, so this is a determinant. Now if we have a 3 by 3 matrix, let's call it A, B, C, D, E, F, G, H, I. So this is a 3 by 3 matrix. So to calculate the determinant, first we have to take the first one, okay, which is A. So this is the first one. So A multiplied by the determinant of. So now we have to eliminate the rows and column of A. So these twos are eliminated, and we are left with only this. So this will write it inside the first determinant. Okay, so it would be E, F, H, I. And therefore the second one now would be a minus. So it is minus the second one after the A is a B. Okay, so minus B. Again, we eliminate the rows and column of B, and therefore we are left with the determinant of D, F, J, and I. Again, for C, we have plus C. Okay, so you have to notice that the sign changes. So first one is positive A, and then it is minus B, and then plus C. So plus C, again we need to eliminate the rows and column of C and write down the determinant of D, E, J, G, and H. Okay, so this is how you have to solve for determinants. Okay, so now to solve this, again have A times the determinant of this one, so EI minus HF minus B times the determinant of this matrix, so DI minus GF plus C times the determinant of DH minus GE. So this would be the determinant of A. So now let's see Cramer's rule. So Cramer's rule states that for a matrix, okay, for example, we have something like this. Let's call it A, B, C, D, F, G, H, I times some unknown which we don't know, x1, x2, x3 for example, and this is equal to another matrix. Okay, let's call it K, L, and M. So you see here, over here we have a 3 by 3 times a 3 by 1 So the answer would be a 3 by 1. So for Cramer's rule, we have to use this to find the 3 unknowns. So Cramer's rule states that, for example, x1 would be the determinant of 1 divided by the determinant of this matrix. Let's call it matrix A here. So this is determinant of matrix A. So where this is, okay, the determinant of 1 is for the value of x1. So this is replace, okay, this is determinant with the first column replaced by this matrix. Let's call this one B, by B. Okay, we'll see an example. Let's see an example so you can understand this rule. So let's say that we have to solve for x1, x2, and x3 using Cramer's rule. So let's suppose we have 3 equations in x1, x2, and x3. So let's call it x1 minus 2x2 plus 3x3 is equal to 12. 4x2 minus 2x3 is equal to minus 1. And 6x1 minus x2 minus x3 is equal to 0. So we have 3 equations of the 3 with the 3 unknowns x1, x2, and x3. Now this 3 equation we can put it as a matrix. So in matrix form, we'll have, so the coefficient of x1, x2, and x3 in a 3 by 3 matrix. Okay, so let's put all the coefficient of x1, x2, and x3. So for x1 is 1, minus 2, and 3. So this is the first one. And the second one, we don't have x1, so it is 0, 4, and minus 2. So this one is 6, minus 1, and minus 1. And times. So in the second one, which is a 3 by 1, we have to put the 3 unknown, x1, x2, and x3. And this is equal to the result, which is 12 minus 1 and 0. This column, okay, over here. So this is also a 3 by 1 matrix. Now, to solve this, we have to find first of all the determinant of A. So let's find the determinant of A, which is 1 minus 2, 3, 0, 4, 2, 6 minus 1 minus 1. So first of all, we take the first one, okay, which is 1, times the determinant, okay, of 4 minus 2 minus 1 minus 1, minus 2. So this one, the second one, minus 2, times the determinant of 0 minus 2, 6 and minus 1, and then plus 3 times the determinant of 0, 4, 6, and minus 1. So we have this. Okay, and again we have to solve for the determinant of the matrix. So we have 1 minus 4 minus 2 plus 2, 0 minus 12, which is plus 12, plus 3, 0 minus 24. This will give you minus 6 plus, so 12 times 2, 24, plus, minus 3 times 24, 72. And therefore, when you solve this, you will have minus 54. So this is a determinant of A. Okay, we also call it, okay, this small triangle to represent the determinant of A. So like this here, this small triangle. Okay, now to find the first one, so x1, we have to find the determinant of x1. So the determinant of 1. Now what is the determinant of 1? So we have to replace the column B over here by the first column of A. So we just have to replace 12 minus 1 and 0 by this column. Okay, it would be 12 minus 1 and 0, and the remaining numbers are just written over here. So minus 2, 3, 4, minus 2, minus 1, and minus 1. Now we have to find the determinant of this matrix, which is 12 times 4 minus 2, minus 1, minus 1, minus minus 2, times minus 1, minus 2, 0, minus 1, plus 3 times minus 1, 4, 0, minus 1. Okay, to solve this, minus 4, minus 2, plus 2, 1, minus minus 2, plus 2, 1 minus 0 times 2 is 0. So plus 3, 1 minus 0. Okay, so it will give you 12 times minus 6 plus 2 plus 3. Okay, this is minus 72 plus 5, which is minus 67. So now x1, okay, x1 is written as the determinant of 1 divided by the determinant of A. So x1 would be determinant of 1 divided by the determinant of A, which is minus 67. Okay, the determinant of 1 divided by minus 54. So it would give you a value of 1.2407. To 3SF is 1.24. So you can solve for x2 by replacing for x2, so you have to replace the second column with the matrix B. So for x2 it would be determinant of 2 square 2, so it is 106, and then we replace it by this column B, 12 minus 1, 0, and then the last one is 3 minus 2 minus 1. And you can solve for the determinant. Again, you will have x2 is equal to determinant of 2 divided by the determinant of a. So for x3, okay, it would be determinant of 3 divided by the determinant of a. So you can check your answers again by doing this. So for x2, you will have 125 over 54. And for x3, you will have 277 over 54. You can check this answer.